Hello everyone. Today we are going to know about some theoretical concepts of complex numbers. So let's proceed. Integral powers of iota. We know that I equal to root over minus 1. So I square will be minus 1 and I cube will be I square into I. So it will be minus 1 into I equal to minus I. Now I to the power 4 equal to I square whole square equal to minus 1 whole square. So it will be 1. So the value of I to the power n for any n greater than 4 is I to the power r, where r is the remainder when n is divided by 4. Next, negative integral powers of iota. I to the power minus 1 equal to 1 by I. We can write it as 1 into I cube divided by I into I cube. So it will be I cube divided by 1 equal to I cube, and I cube will be minus 1. Now I square equal to 1 by I square, I to the power minus 2 equal to 1 by I square equal to 1 by minus 1, so it will be minus 1. Now I to the power minus 3 equal to 1 by I cube equal to 1 into I divided by I into I cube equal to I by I to the power 4 equal to I. Now I to the power minus 4 equal to 1 by I to the power 4 equal to 1 by 1 equal to 1. Now if n greater than 4, then I to the power minus n equal to 1 by I to the power n. So it will be 1 by I to the power 4, where r is the remainder when n is divided by 4. Now, how to find the modulus and argument of z1 into z2? Mod of z1 into z2 equal to mod z1 into mod z2. That is, the modulus of the product of two complex numbers is equal to the product of the modulus of each complex number. Now, some remarks. If minus pi less than argument of z1 plus argument of z2 less or equal to pi, then argument of z1 into z2 equal to argument of z1 plus argument of z2. If minus 2 pi less than argument of z1 plus argument of z2 less or equal to minus pi, then argument of z1 into z2 will be argument of z1 plus argument of z2 plus 2 pi. Now if pi less than argument of z1 plus argument of z2 less or equal to 2 pi, then argument of z1 into z2 equal to argument of z1 plus argument of z2 minus 2 pi. Now how to find the modulus of z1 by z2? Mod of z1 by z2 equal to mod z1 by mod z2, that is the modulus of the division of two complex number is equal to the division of the modulus of the individual complex numbers. Now argument of z1 by z2. If minus pi less than argument of z1 plus argument of z2 less or equal to pi, then argument of z1 by z2 equal to argument of z1 minus argument of z2. Now if minus 2 pi less than argument of z1 plus argument of z2 less or equal to minus pi, then argument of z1 by z2 will be argument of z1 minus argument of z2 plus 2 pi. Now if pi less than argument of z1 plus argument of z2 less or equal to 2 pi, then argument of z1 by z2 will be argument of z1 minus argument of z2 minus 2 pi. Now cube roots of unity. To find the cube roots of unity, let us consider the cube root of 1 equal to x. Therefore, cube root of 1 equal to x, or 1 to the power 1 by 3 equal to x. Therefore, x cube equal to 1. Now, x cube minus 1 equal to 0. Now, a cube minus b cube formula will be a minus b into s square plus ab plus b square. With the use of this formula, we can write it x minus 1 into x square plus x plus 1 equals to 0. So either x minus 1 equals to 0 or x square plus 1 plus x equals to 0. Therefore, x equals to 1 or x square plus x plus 1 equal to 0, or x square plus 2 into x into half. We can write it in the form plus half whole square plus 3 by 4 equals to 0. or x plus half whole square equal to minus 3 by 4. A square plus 2ab plus b square will be a plus b whole square. Now x plus half equal to plus minus root over 3 root over minus 3 by 2, or x plus half equal to root 3 by 2 into I, or x equal to half whole bracket minus 1 plus minus root 3I. Therefore the 3 cube roots of 1 are 1 minus half plus root 3 by 2 into I, minus half minus root 3 by 2 into I. Among the 3 cube roots of 1, one is real and the other two are imaginary. So this is for today's class. Keep watching, comment, share, like and subscribe.